This is question number 9. We're told a pencil holder is in the shape of an open circular cylinder of radius r centimetres and height h centimetres. The surface area of the cylinder, including the base, is 250 centimetres squared. In part A for 4 marks, we need to show that the volume v centimetres cubed of the cylinder is given by v is equal to 125r minus pi r cubed over 2. Let's go ahead and draw a quick sketch. So what we're going to have then is a circle on the top and a circle on the bottom. We've been given now the dimensions in terms of r and h. So if I go ahead and put these on, we've got now the height, which will look something like that. And let's just move this into place. And let's put that just there. And then we're going to have now the radius. So if I just pop this on, let's look at this. So what we've got then is this radius, and this, remember, doesn't have a top. We can put a radius here or we can put it here, it doesn't really matter. We've got a radius of r and a height of h. So if we just put these on, this is going to be r, so this is r, and this is going to be h. If we look now at the volume of this particular cylinder can be written as the area of the cross section, which is pi r squared, multiplied by the height, which is h. What I'm now going to do is look at the surface area. The surface area I'm given now is 250 centimetres squared. This now is an open top cylinder. So if we just draw a quick sketch, let's put this on and we can go ahead and do the net. It's going to look something like so. So that gives us our cylinder. We know that the area of the circle is going to be pi r squared. If we consider this length right here, this, if it wraps around the circle, is going to be the circumference of the circle, which is going to be 2 pi r, and this one is going to be h. Therefore, the area of this part right here is going to be 2 pi r h. So we've got the area here, and the area is going to be equal to pi r squared plus 2 pi r h. So that is an expression for the area. What we're given is that this area is 250 centimetres squared. I need to show that the volume can be written in this form. What we can see here is that the volume here doesn't have h in. So what I'm going to do is substitute now in the area is 250, and that's going to be equal to pi r squared plus 2 pi r h. I'm going to make h the subject of this particular equation here and then substitute it into the volume. So we can say now that 250 minus pi r squared divided now by 2 pi r is going to be giving us the value of h. We can of course simplify this if we like. We could write this now as 125 over pi r. Then we're going to have minus now, this is going to give me r over 2. So let's just check that's all right. That looks perfectly fine, and that is the height. So all I've done is rewritten it. You don't have to simplify that fraction. I'm going to, and then just substitute it in. Therefore, what we've got is that the volume is going to be equal to pi r squared height, and that's going to give me the 125 over pi r minus now the r over 2. If we multiply this out, we're going to get on here, we've got the pi and the pi will cancel, the r squared and the r will cancel to give us 125r, minus, then we're going to have pi r squared multiplied by r is r cubed divided by 2, and that gives us now the value required. So all we've done is gone ahead and done that. So that part is done now for 4 marks. In part B, it says now use calculus to find the value of r for which v has a stationary value. This part carries 3 marks. So even if you couldn't do this last part, now you can use the result they've given. So what we want to do then is say differentiating both sides of the equation with respect to r, dv dr will be equal to 0 for stationary points. So for SP. So let's just differentiate this. What we have then is dv dr is going to be equal to 125. Then we will have now multiplying down by the power, we're going to have 3 over 2 pi r squared. So this is what we end up with. So I've just differentiated here. Setting this equal to 0, I could of course write now that 3 pi r squared over 2 is equal to 125. You might want to show that that's 0. I've stated it here and I've just added this to both sides. So what we can say from here now is that r is going to be equal to the square root of 250 over 3 pi. I'm just simply solving this equation for r. We're going to take the positive root. We technically should say plus or minus. As it's a radius, it will be the positive root. I've just multiplied by 2, divided by 3 pi, and taken the square root. So let's go ahead and do that, and we will find now the value of r, so 250. So 250 over 3, and then we're going to have pi. That's going to give me on here 5.15. So r is going to be equal to 5.15. And now we're looking at this, and this of course is in centimetres. So use calculus to find value of r. Well, that's going to be 5.15 centimetres, and that now is to 3 SF. So that's exactly what is required in this part. Prove that the value of r that you found in part B gives a maximum value for v. We need the second derivative, and we can say that d2v by dr squared, we want to show that this is going to give a maximum value. This will be less than 0 for max. So just jotting this down, less than 0 for max. So if we now pick this up here, what I'm going to do is d2v by dr squared. So d2v by dr squared, well, that is going to give me 0. And this is simply going to be multiplying down by the power. Remember, we're differentiating r here. It's going to be minus 3 pi multiplied now by r. We can see now that when r is equal to the 5.5, so we can say now from here that, and just subbing this in, we can say minus 3 pi multiplied now by the 5.15 is going to be less than 0. Therefore, we've got a max. So that now gives us what we want. So 2 marks for that part. Calculate to the nearest centimetre cube the maximum volume of the pencil holder. So what we've got here is the formula here, and we simply need to sub our value in. So for 2 marks, I'm going to put this in, and let's just write it here. We'll have now the volume. So the volume is given now as 125. Then we can have our 5.15 that we've got in the calculator, minus pi multiplied by the 5.15 ... cubed over 2. So I'm just going to store this in case I make an error. Shift store A. So what we've got then is 125 of the A, then minus now our pi, then we're going to have pi, then our answer which we need to cube, and then we're going to divide that by 2. So that's just substituting straight into here now, and that's going to give me 429.19. So to the nearest centimetres cubed, that's going to give me 429. So 429 centimetres cubed, and that now is to the nearest centimetre cube. I probably put in my my value just here and then just round it at the end.